So continuing on with composite functions, we looked at how to do composite functions with equations and function notation. Now we're going to look at a table method. So tables or functions can be represented in tables with graphs, and so the composites look, a little bit different in each situation, but they're basically the same idea, taking the output from one function and using it as the input for another. So let's look at a couple examples here. I've got a table with all x values along the top. Those are the inputs. The outputs for the f function in the middle, and the outputs for the g function along the bottom. Now, just as a couple examples to see how this table works, if I wanted to find f of 1, 1 being the input, 2 being the output for f. Alright, so if 1 is the input, 2 is the output. If I wanted to look at f of 4, 4 being the input, 3 then is the output. If I wanted to find g of 0, for instance, 0 is the input, 1 is the output for g. And if I want to do g of 2, well, 2 is the input, 0 is the output, so we get g of 2 equals 0. Now we can look, so that just gives you an idea of the input-output idea. Now we can look at some composite functions using the same information. So we have f circle g of 2. Now when we write this out in composite form, the f is on the outside, it's the first one listed, the g is on the inside, it's the second one listed. So this becomes f of g of 2. Okay, 2 is the input to g. So we go 2 in the x and the output 0. So we have f of 0. And of course, if we look at 0 as the input, f of 0 is 0. The output is 0. Okay. Let's look at another function. We can do a bunch of these. We could try f circle g of 1. Again, keep them in the order they're listed, so f is on the outside, g is on the inside. F of g of 1. Now the g of 1 is what I'm going to replace with its output. So 1 is the input, g of 1 is 3. Then you do f of 3. So 3 is the input, and f becomes 1. The f function is 1. Okay, so f of g of 1 is equal to 1. Let's switch the order. It doesn't matter what order these are in. We could do g of f of 2. Again, keep the order the same. G is then on the outside, f is on the inside. Okay, f of 2 is going to be my first output. So 2 is the input. F of 2 is 4. Then 4 is the input to g. G of 4 is 4. Okay. So that means g of f of 2 is equal to 4. We can even compose a function with itself. We could try f of f, or f circle f of 2. Again, the first one is on the outside, second one is on the inside. F of 2. So f of 2 is our first output. The 2 goes in, 4 comes out. Then f of 4, you put a 4 in, and 3 comes out. But you're doing both of those on the f row. Right? And now we could go real crazy, and we could take f circle g circle f circle g of 0. Now that looks crazy, but we're just composing a bunch of functions all one inside the other. And so again, you work from right to left. So we're going to do g of 0, and then f of that, and then f of that, g of that, and f of that. So we'll start with g of 0. The output, we plug in 0, get 1 out. Then you do f of that. Okay, so f of 1. 1 is the input, 2 is the output. Then you do f, so we did the g, we did the f. Now we're doing the next f. So it's f of 2. 2 is the input, 4 is the output. Okay, that takes care of that f. Now we're going to go to the g. So it's g of 4, sorry. So 4 is the input, then 4 is the output. And finally, that takes care of that. And finally, we do the last f. And f of 4, we get 4 as the input and 3 as the output. And there it is. Okay. So moving backwards, starting at 0, then you do g, f, f, g, f, you end up with 3. Okay, so that's just some ideas if you have a table of values, how to represent those with composite functions. And yeah, we'll continue in the next video.